Now let's see here. Okay. So what we studied in yesterday class? Danny,
Yes, sir.
Danny,
Yes, sir.
लास्ट क्लास में क्या पढ़ा था हम लोग?
Hello.
लास्ट क्लास में क्या
Last
पढ़े
class में
थे?
क्या पढ़ा? Children like working.
Now let's see here. Vertical clamp screw. What is this? Vertical circle. This is what? Vertical circle. Okay. And this is vertical clamp. All right.
Yes, sir.
This is a screw. Okay. And this is a spring loaded. Okay. So basically, this is what? A spring loaded plunger. A spring loaded plunger. Okay. All right.
Yes, sir.
So draw the figure. Draw the figure. And this is what? Tangent screw. So what happened? Basically, vertical circle and telescope, as we have discussed yesterday, that they are clamped together. They move. The relative moment is zero. So obviously the vertical circle and telescope can be clamped at any desired vertical angle. Vertical circle and telescope can be clamped at any desired vertical angle with the help of vertical tangent screw. With the help of vertical tangent screw. That means if you clamp the if you clamp the telescope and vertical circle with the help of vertical clamp screw, then the rotation of telescope is prevented. Rotation of the telescope is prevented. So basically, vertical clamp, what we say? Vertical clamp screw. What it said? Prevent the rotation of the telescope. Rotation of telescope plus theodolite plus theodolite sorry, plus vertical circle plus vertical circle. All right. And once, if you clamp the vertical, if you clamp the screw so that you can prevent the movement of the vertical circle as well as telescope, तो उसके बाद आपका हो सकता है कि स्मॉल रोटेशंस हो सका है. Small rotations can may take place. Okay, so that small rotations even after tightening of vertical clamp screw can be prevented with the help of vertical tangent screw. So ये after this a small rotation may take place. A small rotation may take place. A small rotation may take place. All right. After that, a small rotation may take place, which can be prevented with the help of prevented with the help of with the help of what with the help of tangent screw. With the help of tangent screw. That means if you want to fix the telescope at particular angle so that even not a slight rotation is permitted, slight rotation भी permit नहीं करना चाहते हैं आप, तो आप you can use the vertical tangent screw. You can use the what? you can use the vertical tangent screw. So draw the figure and write down. Now let's see here. That is the lower plate. That is the lower plate. All right. Upper plate हम लोगों ने डिस्कस किया था लास्ट क्लास में. लोअर प्लेट. लोअर प्लेट को हम लोग स्केल प्लेट.
Sir, no voice.
Audible. Now it's audible.
Yes, sir.
Okay. बैटरी खत्म हो गया था. Now let's see here. So what is the lower plate? Lower plate is what? Scale plate or horizontal circle. So what we can say that this is what? This is the lower plate. The lower plate is attached to the spindle, outer spindle. All right. So basically a spindle क्या है हमारा? Basically क्या है हमारा spindle? This is what? This is the outer spindle. Okay, this is the outer spindle. All right, and this is what? Inner spindle. Both are coaxial. दोनों क्या होता है? Coaxial होता है हमारा. So lower plate क्या होता है? It carries a horizontal circle. It carries a horizontal circle. That's why it's known as a scale plate. And it is leveled, and that scale is graduated from 0 degree to 360 degree. Upper plate was 0 degree to 90 degree. Here 0 degree to 360 degree in clockwise direction. And each degree is subdivided into where? 2, 3 or 4 divisions. 2, 3 or 4 divisions. So horizontal circle readings are taken by the means of vernier A and B. Earlier it was vernier C and D. Here it is vernier A and B. All right. Here it is vernier A and B. Now let's see here. Now let's see here. Now it's what? Now it's vernier A and B. So it contains vernier A and B. Remember, A and B vernier. So lower plate carries a lower clamp screw. Lower plate के पास क्या होगा? Lower clamp screw होगा. All right. And with the help of tangent screw as well as with the help of clamp screw, the position of the what? Telescope can be fixed in any directions in the horizontal, the position of which, I mean position of this lower plate can be fixed in any direction. ठीक है ना? Can be fixed in any डायरेक्शन, जिस डायरेक्शन मुझे चाहिए. सो जब आप क्लैंप स्क्रू को टाइट करते हैं तो प्लेट हमारा फिक्स हो जाता है विद टू द ट्राई ब्रैच, टू द ट्राई ब्रैच. फिक्स्ड प्लेट इज फिक्स्ड टू द ट्राई ब्रैच. दिस इज व्हाट? दिस इज ट्राई ब्रैच. So when clamp is fixed, this lower plate is fixed to the what? Tri branch. This lower plate is fixed to the tri branch. All right. So obviously lower plate can also be fixed in position with the help of corresponding slow motion or tangent screw. So size of the theodolite is always determined by the size of what? Size of बोलो डैनी.
Yes,
सो
sir.
गया क्या? मैंने बताया था ना लास्ट क्लास में कि साइज ऑफ theodolite इज गवर्न्ड बाय अपर प्लेट डाया और लोअर प्लेट डाया.
Upper plate.
No, lower plate. I already told you, size of the theodolite is represented by the size of the lower plate. All right.
Yes, sir.
तो कॉपी नहीं पढ़ते हो? हाँ?
Sorry.
Not reading copy.
Reading. But not this time,
No,
sir.
you are not reading copy. Okay. Now let's see here. So basically, lower plate or scale plate or horizontal circle. हो गया? So lower plate, I already told you, this is attached to the outer spindle. Attached to the outer spindle. And as well as it carries a horizontal circle at its beveled edge. Beveled matlab like this way. This is the beveled edge. This way, this is the what? Beveled edge. So that's why it's known as second scale plate. Also known as scale plate. Also known as scale plate. So obviously we can say that it's also its position can also be can also be defined with the help of lower clamp screw. In upper plate we have upper clamp screw, here we have lower clamp screw. So we can say that it is divided into, or the scale is divided, scale is graduated from 0 degree to 360 degree in clockwise direction. In clockwise direction. All right. As well as we can say that its motion, okay, it carries a lower plate screw and corresponding slow motion or tangent screw with the help of which it can be fixed accurately. It can be fixed accurately. All right, in any direction. So we can say that it has lower clamp, not upper clamp. It has lower clamp screw. Lower clamp screw plus tangent screw. Tangent screw prevents the slight rotation as as we have studied earlier. All right. Also, जब आप क्लैम्प को टाइट कर दीजिएगा तो प्लेट किससे फिक्स होता है? ट्राई ब्रैच से. ट्राई ब्रैच से फिक्स टू द ट्राई ब्रैच आफ्टर clamping of screw. Yeah, after clamping its position. All right. And last but not the least, size of a theodolite is determined by the dia of lower plate. If we can say that lower plate is 20 centimeter dia, it means that size of the theodolite is 20 centimeter. All right. Write down.
Sir.
Now let's see here. This is what? Vernier A. This horizontal circle carries vernier N and vernier B, with the help of which we can take the readings. So this is what? Outer spindle, this is inner spindle, and this is lower clamp. Okay. So with the help of this clamp and screw, we fix the position of the telescope, and with the help of vernier A and vernier B readings, we take the readings of the horizontal circle. So write down.
Start this diagram.
First write down. The horizontal circle readings are taken by means of by means of vernier A and vernier B. Underline it. The vernier horizontal circle readings are taken by means of vernier A and vernier B. Vernier A and vernier B. Written.
Yes, sir.
Draw this figure now. Now let's see here. Upper plate or vernier plate. Okay. So basically upper plate or vernier plate. तो upper plate क्या होता है? Upper plate is on the vernier A and B. Okay. Upper plate rests on where? It rests on the, we can say that it is attached to the inner axis. It is attached to the inner axis or inner spindle or inner spindle. All right. So basically its movement is controlled by upper clamp screw, and further slight rotation is prevented by upper tangent screw. So upper plate or vernier plate is attached to the inner axis, and it carries two verniers, also same vernier B and vernier A. Vernier B and vernier A, that is diametrically opposite. So basically upper plate also supports the standard or A frame. All right. So remember one more thing. So remember one thing, upper tangent screw is always used for making a small movement of the upper plate, okay, and tightening upper plate. So once the upper plate is tightened or clamped, you have clamped upper plate. Then and lower plate is unclamped. Then both plate will move as a single unit. Both plate will move as a single unit. This may be asked in objective examination. So remember this. This may be maybe both will move as a single unit. So remember, both upper and lower plate, clamp screw clamped. Both upper and lower clamp screw clamped. Then there will be no movement of theodolite. There will be no movement of theodolite. All right. Lower clamp screw tight, upper clamp unclamped. Then lower plate does not move, but upper plate moves. Since upper plate moves, vernier A and vernier B reading will also change. Vernier A and vernier B reading will also change. All right. Next, lower clamp screw unclamped, lower clamp screw unclamped, and upper clamp screw clamped. Then both will move as a single unit, and in that case, since upper plate is clamped, then there will be no change in the vernier of the horizontal circle. Readings as measured by verniers will not change. Why? Because the moment of vernier with respect to horizontal circle reading is zero, as the upper plate is clamped. But upper plate is clamped and lower plate is unclamped, then both will move as a single unit. Remember, this type of things are generally asked in objective questions. All right. Got it? Danny?
Yes, sir.
Now write down. Upper plate or vernier plate. Upper plate or vernier plate. Upper plate or vernier plate. Written.
Yes, sir.
First point. Upper plate contains the vernier scale A and B. The upper plate contains the vernier scale A and B. Written.
Yes, sir.
Second point, upper plate or vernier plate is attached to the inner axis or inner spindle. Inner axis or inner spindle. Written.
Yes, sir.
Now write down the movement upper plate. Its upper plate. Yeah, its movements is controlled by the upper clamp screw. Its movement is controlled by the upper clamp screw and the upper tangent screw. Its movement is controlled by the upper clamp screw and upper tangent screw. हो गया?
Yes, sir.
Next, uh, write down a note. Write down note, 3 notes, very important. All right.
Sir.
Both upper and lower plate clamp. First, write down 3 notes. First, both both upper and lower clamp screw clamped. Both upper and lower clamp screw clamped. Both upper and lower clamped screw clamped. Both upper and lower clamped screw clamped. Written.
Yes, sir.
लिखिए. When both will be clamped, then write down no movement of theodolite. No movement of theodolite. Written.
Yes, sir.
Second, lower clamp screw tightened. Lower clamp screw tightened. Lower clamp screw tightened, and upper upper clamp screw unclamped, and the upper clamp screw unclamped. Written.
Yes, sir.
Then लिखिए. Then lower plate does not move as upper plate moves. Lower plate does not moves and upper plate moves. Lower plate does not moves as upper plate moves. Written.
Yes, sir.
So remember one more thing. If lower plate does not moves but upper plate moves, and that vernier is being carried by upper plate, so vernier will also moves, and hence while taking recordings before the movement and after the movement, the vernier readings will be different. All right. So hence vernier moves. Hence vernier moves and vernier readings before the movement and before readings sorry before and sorry and vernier readings before the movement and vernier readings before the movement and after the movement and vernier readings before the movement and after the movement will change, and the vernier readings before the movement and after the movement will change. Clear hai?
Yes, sir.
Now write down third. Lower clamp screw unclamped. Lower clamp screw unclamped and upper clamp screw clamped. So since upper clamp screw is clamped, although lower clamp screw is unclamped, but when both will move together as a single unit. But since this upper clamp screw is unclamped, then obviously if it will move, the vernier readings will change. Okay, so write down both upper and lower plate, both upper and lower plate, both upper and lower plate move as a single unit. Both upper and lower plate will move as a single unit. Written.
Yes, sir.
Since upper clamp screw is tightened, since upper clamp screw is tightened, the readings as measured by verniers will not change. The readings as measured by verniers will not change. The readings as measured by verniers will not change. Written.
Yes, sir.
Now let's see here. This is what you are seeing here. This is standard or A frame. This is what standard or A frame, like this way. All right, able to see
Sir.
like this way. Okay,
Yes, sir.
so this is what standard or A frame. So basically there are two standards that resemble the A, that resemble the A. Let's see here. Now let's see. This is what, this is, you are seeing A frame, that is the components of alligator assembly. Getting or not?
Yes,
So
sir.
basically, these two standards that resemble the A letter, that is, this is mounted on which plate? This is mounted on upper plate. This is mounted on upper plate. All right.
Yes, sir.
So basically, why this is mounted? This supports the telescope as well as vertical circle. Okay. And basically, this telescope, this is mounted on this A frame. It provides the support. Okay, and the T frame as well as arc of vertical circle clamp. This is vertical circle clamp as well as T frame. This is also what attached to the A frame. This is also attached to the what A frame. This is also attached to the A frame. All right. All right.
Yes, sir.
So write down two standards resembling standards or A frame. Write down standards or A frame. Standards or A frame. So two standards resembling the letter A. Two standards resembling the letter A, capital A. Two standards resembling the letter capital A that are mounted on the upper plate. are mounted on the upper plate. Written.
Yes, sir.
To support the telescope, to support the telescope, to support the telescope, comma, vertical circle, vertical circle, and the Trunnion axis of the telescope, and the Trunnion axis of the telescope. Written.
Yes, sir.
Now write down allied assembly. एक मिनट रुको. Two standards resembling the letter A written na.
Yes, sir.
So after A, write down in bracket forming an U frame. After A, write down in bracket forming an U frame, capital U, capital U frame, capital U frame. Okay.
Yes, sir.
Now write down allied assembly. Allied assembly written.
Yes, sir.
Now retain one more thing. As I did now understand one thing. Allied assembly. So allied assembly consists of what? Telescope, U frame, as well as altitude bubble. So write down consist of telescope, comma, U frame, and vertical circle, U frame, vertical circle, U frame, vertical circle, retain, hmm? Retain,
Yes, sir. Yes, sir.
U frame,
Got.
vertical circle, comma, altitude bubble. So this is what? So basically this is what? This portion is from here to from here. This is allied assembly. This is allied
Yes,
assembly.
sir.
Now write down horizontal circle assembly.
Sorry, sir.
Horizontal circle assembly. So in this horizontal circle assembly, we have upper plate as well as lower plate. Getting na? So this upper plate and lower plate. So one more thing, remember, this upper plate carries vernier and lower plate carries the horizontal circle, which is graduated in 0 to 360 degree. All right.
Sir.
So write down horizontal circle assembly. So write down horizontal circle assembly. Horizontal circle assembly consists of lower and upper plates. Consist of upper and lower plates. लिख लिए?
Yes, sir.
Write down the lower plates. Lower plate carries the main scale. Bracket में horizontal scale. Lower plate carries the main scale. Bracket में horizontal scale. And upper plate carries the verniers. And the upper plate carries the vernier. Written.
Yes, sir.
Now write down leveling head assembly.
Sir.
So see here. In leveling head assembly, क्या आप देख पा रहे हैं? Are you able to see that
Yes, sir.
this leveling head assembly, this consists of this consists of what? Triangular plates. One is upper triangular plates and another is lower triangular plate. So this basically in leveling head assembly, this consists of two parallel triangular plates. So they are known as tri-brach. TRIBRACH. What are they are known as? Upper plate is known as what? This is known as tri-brach. अरे यार. This is known as tri-brach. Okay. So it consists of tri-brach at what? Rivet. Okay. It has rivet. Okay. So obviously it consists of foot screw and rivet. Okay. So this leveling screw that works in the threaded holes. This is what threaded holes. All right. So in this working threaded holes in the tri-brac arms. Okay. And this lower end of this tri-brac, lower end of this tri-brac represents the trivet. Represents the what? Trivet. Okay. So lower end of the tri-brach, lower end of the tri-brach resting holes of trivet. Holes of trivet. All right.
Yes, sir.
So obviously this help of this foot screw, this 3 foot screws are there. So with the help of this foot screw, we can label the instrument. We can label the instrument. So lower tri-brach plate or foot plate, that has a circular hole. So from circular hole we can suspend a plumb bob. So there is upper plate or upper tri-brach, lower tri-brach. So lower tri-brach plate has a circular hole. Okay, has a circular hole. And obviously on this upper tri-brach plate we have 3 leveling screw, with the help of which we can label the instrument, which with the help of which we can label the instrument. All right. That means the vertical axis can be made truly vertical. The vertical axis can be made truly vertical. All right.
Yes, sir.
So obviously a circular bubble is also provided on this upper tri-brach. Why circular bubble is provided? So basically circular bubble is provided to put the horizontal, sorry, circular bubble is provided to put the horizontal circle into horizontal plane. So this leveling head function two things. First, to make the true vertical axis of the instrument truly vertical, and to make the horizontal circle into horizontal plane. So write down leveling head usually consists of the leveling head usually consists of Written.
Yes, sir.
So write down the leveling head usually consists of two parallel triangular plates. Two parallel triangular plates known as tribrach, TRIBRACH plates.
Yes, sir.
Also bracket में also consist of या ट्राइब्रैच के बाद लिखिए which contains 3 or 4 screws.
Sir.
Wait a minute. हो गया? हाँ. So write down the upper tribrach has 3 arms, each carrying a leveling screw. Upper tribrach has 3 arms, each carrying a leveling screw. 3 arms and each carrying a leveling screw. Written.
Yes, sir.
The lower tribrach plate or foot plate or trivet stage. The lower tribrach plate. uh, the lower tribrach plate or trivet stage. The lower tribrach plate or trivet stage or foot plate or foot plate or foot plate or foot plate has a circular hole through which a plumb bob can be suspended. Has a circular hole through which plumb bob can be suspended. Through which plumb bob can be suspended. Written. Through which plumb bob can be suspended. Written.
Yes, sir.
So basically what we can say that what are the functions of this leveling head? Basically leveling head performs 3 types of functions. What it does, it supports the main part of the instrument, that is above assembly. Second, it's also attached the theodolite to the tripod because the lower plate can be attached to the tripod with, okay. And third, for providing a means of leveling the theodolite because it has 3 level, it on the upper plate of this tribrach, it has 3 leveling screw with the help of which we can level the instrument. Okay.
Yes, sir.
Now, now write down 2 spindles or axis of center. 2 spindles or axis of center. Written. So remember one thing, inner spindle or axis, that should be solid and conical, and it fits into the outer spindle which is hollow and ground conical in the interior. All right. So inner spindle is what? Let's see here. Now let's see here. This is what? This is the outer spindle and this is in the inner spindle. Both have same axis. That both are coaxial. So inner spindle is also called upper axis. Also called upper axis. All right. As well as, because why it called the upper axis? Because it carries the upper plate. It carries the what? Upper plate. It carries the this upper plate. This it carries this upper plate. So it called upper axis. All right. As well as vernier. Okay, so this outer spindle carries the a scale or lower plate. This outer spindle, it carries what? A scale or lower plate, or we can say the horizontal circle or lower plate. So it's known as what? Lower axis. So both the axis should have, both the spindle or both the inner axis as well as outer axis, they have a common axis which forms the what? Vertical axis of the telescope, which also forms the vertical axis of the telescope. All right.
Yes, sir.
So write down inner spindle or axis, inner spindle or axis that is conical, that is hollow and conical. All right. That is hollow and conical. All right.
Yes, sir.
Inner axis also known as upper axis. Why? As it carries upper plate and hence vernier A and B. Okay. Lower axis or lower, or we can say that outer spindle or outer spindle is known as lower axis. Outer spindle is also known as lower axis as it carries lower plate or lower scale, or we can say that horizontal scale. Okay, scale plate. Okay, remember both outer and inner spindle forms a common axis which is also the vertical axis of telescope. Vertical axis of telescope. All right.
Yes, sir.
Write down. Write down compass. Compass can be tubular type or trough type. Can be tubular type or trough type fitted with a screw. All right. Done.
Yes, sir.
So whenever there are some telescopes which are fitted with a striding level. What is this? striding, striding level. Why? What is the purpose of this striding level? Basically, what happen in if you want to test the horizontality of the transit axis or Trunian axis or horizontal axis, then you need a striding level. So write down. It's used to test the horizontality of the transit axis or Trunian axis. Used to test the horizontality of the Trunian axis or transit axis or horizontal axis. All right, written.
Yes, sir.
So basically, we discussed that what we have altitude level we have altitude bubble. We have altitude bubble. You are seeing this altitude bubble. This altitude bubble is provided where? This is provided on the top of the index bar. This is what? This is what? Index. So this is what? Index bar. Okay. So write down its altitude bubble. It is a long sensitive bubble. It's a long sensitive bubble provided on the top of index frame or T frame or vernier frame. Index frame or T frame or vernier frame. Index frame or T frame or vernier frame. Let's see here. You are seeing this altitude bubble on this T frame on the low horizontal on the vertical circle. All right. Getting my points?
Yes, sir.
Getting Danny? So basically, this altitude bubble is provided on the top of the what? On the top of the vertical circle or T frame or index frame or vernier frame. All right. Written.
Sir.
Next, write down. Wait. Trivet. Written.
Yes, sir.
So trivet is also known as what? That is the lower tri ब्रैच प्लेट. मैंने लिखवाया है फुट प्लेट देखो और ट्रीवेट प्लेट लिखवाया है ना लोअर प्लेट और लोअर ट्राई बैच प्लेट में लिखवाया है कि नहीं? So it is the lower plate of the theodolite or foot plate. It is the lower plate of the theodolite or foot plate. Write down. It is the lower plate of the theodolite or foot plate. Written. लिख लिया.
Yes, sir.
It is the lower plate of the theodolite or foot plate that allows the instrument to be placed on a tripod stand. That allows the instrument to be placed on a tripod stand. that allows the instrument to be placed on the tripod stand, that allows the instrument to be placed on the tripod stand
Yes, sir.
and has a large threaded hole, and has a large threaded hole, and has a large threaded hole written,
Yes, sir.
and has a large threaded hole that can be, and as a large threaded hole in the center allows the instrument to be and a large threaded hole in the center that can be used to suspend a plumb bob, that can be used to suspend a plumb bob, that can be used to suspend a plumb bob written.
Yes, sir.
Now write down shifting head. Now write down shifting head. All right, written.
Yes, sir.
So basically what is shifting head? Basically suppose कीजिए कि your instrument is on the tripod, okay, and it remains stationary, your tripod should remain stationary, but you want the instrument to be slight movement, you want the instrument to be slight moved, okay, you want a slight movement of the instrument in the horizontal plane, okay, although the tripod should be stationary, tripod stationary hona chahiye, but you want a slight movement of the instrument, so that can be done with the help of what? That can be done with the help of shifting head. So also exact shifting can also, exact centering can also be done with the help of shifting head. All right, so the instrument is first approximately centered over the station with the help of tripod legs, ओके, ट्राइपॉड लेग्स को सरकमफ्रेंशियली हम लोग क्या करते हैं, लेवल करते हैं, उसके बाद अगर आप चाहते हैं एग्जैक्ट सेंटरिंग हो तो दैट कैन आल्सो बी डन विद द हेल्प ऑफ शिफ्टिंग हेड. सो क्वेश्चंस में भी आस्क कि शिफ्टिंग हेड क्या रिप्रेजेंट करता है हमारा. देखो दिस इज व्हाट, दिस इज शिफ्टिंग हेड, दिस इंस्ट्रूमेंट इज व्हाट, शिफ्टिंग हेड. ऑलराइट, दिस इज व्हाट टाइप ऑफ शिफ्टिंग हेड. गेटिंग माय पॉइंट्स?
Yes,
समझ
sir.
रहे हो? सो जाता है क्या तुम?
Sorry, sir.
You slept while studying
No,
as you used to do in class.
no.
When you will coming offline?
Uh,
After Diwali.
yes, sir.
So write down. Shifting head allows the slight movement of the instrument in the horizontal plane. Shifting head allows the slight movement of the instrument in the plane horizontal plane horizontal plane with the tripod remains stationary. With the tripod remains stationary. हो गया?
Yes,
Written.
sir. Yes, sir.
Write down note. Exact centering can also be achieved with the help of shifting head. After exact centering can also be achieved with the help of shifting head. Exact centering can also be achieved with the help of shifting head. Written.
Yes, sir.
After approximate centering of the instrument, after after approximate centering of the instrument with the help of with the help of tripod legs.
Sir.
Written.
Sir.
Chalo. Next, write down. Next, we'll do another class. Okay. Okay.
Yes, sir.
We have class on Monday. Okay. Schedule will be posted tomorrow. Okay.
Okay, sir.